This video is about the pumping lemma, specifically for context-free languages. Context-free languages are a class of formal languages used extensively in computer science, especially in the design and analysis of programming languages and compilers. The pumping lemma is a tool to prove whether a language is context-free or not. The pumping lemma is a mathematical tool used to prove that certain languages are not context-free. If a language violates the pumping lemma, then it is not a context-free language. However, it is important to remember that satisfying the pumping lemma does not automatically mean the language is context-free. It just means the lemma cannot be used to prove that it is not context-free. Here's the formal statement of the pumping lemma for context-free languages. If L is a context-free language, then there exists a pumping length P such that every string S belonging to L with the length of S greater than or equal to P can be divided into 5 parts. If S is a string that satisfies the conditions for pumping, it can be divided into 5 substrings, denoted as U, V, X, Y, and Z. Therefore, S is equal to U, V, X, Y, Z. Now, let's discuss the pumping conditions that these substrings must satisfy. Firstly, the length of Vxy must be less than or equal to P, where P is the pumping length. Secondly, the length of Vy must be greater than or equal to 1, which means V and Y cannot both be empty strings simultaneously. If a language L is context-free, then for all I greater than or equal to 0, uv to the power ix y to the power iz must also be in L. This is the core property used to prove that a language is not context-free. By choosing a suitable string and pumping it, you can show that the resulting string is not in L, leading to a contradiction. Now let's explore how to use the pumping lemma to prove that a language is not context-free. First, assume that the language L is context-free. Then choose a string that leads to a contradiction. By applying the pumping conditions and the pumping property, you can derive a contradiction, which proves that the initial assumption that L is context-free is false. Therefore, the language is not context-free. Let's consider an example to illustrate how to apply the pumping lemma. We want to prove that the language L is not context-free, where L consists of strings in the form of a to the power n, b to the power n, c to the power n, such that n is greater than or equal to 1. This language requires the number of a's, b's, and c's to be equal, which is a classic example often used to demonstrate the pumping lemma. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.